that current can actually flow through you. There's power available in this socket. I'm not getting anything. Hi everyone, nice to see you again. Today's video is focusing on usage of some of our tools. We'll also look at how to use a multimeter for simple tests and even understanding some of these current ratings when we see on our appliances. We're going to start off with how to use some of these basic tools such as a flat tip screwdriver and a Phillips screwdriver. Now, as you can see clearly from the tip, it is actually very different. One is a flat surface and the other one has got grooves on it. Now, the difference between the two, of course, is, for example, if I were to bring this into the picture, this is a simple 3-pin plug. If you can see this securing screw, it's got grooves on it. Let's try to see which one is the most suitable. Now, if I were to use a flat tip screwdriver, it does fit very nicely into the groove and I am able to rotate the screw relatively easily. Now, if I were to use the Phillips screwdriver, it sits very nicely in the groove and the torque that I need to open the screw is a lot easier to be applied because this Phillips screwdriver has got a greater contact area as far as the screw is concerned. The idea here is to use the most suitable screwdriver for your application. If you misuse your tools, it'll cost you because you need to replace them. Cost of two such screwdrivers I've mentioned before in my previous videos, relatively inexpensive, $5-6, you can get a decent set. Now, let's try to open up this using a Phillips screwdriver. I'll unscrew the cover. You notice this is a magnetic screwdriver, so my screw doesn't fall off so easily. Typically, in order to unscrew or tighten these screws, I will use a test pen. Can I use a flat tip screwdriver? Yes, I can to some extent, but again, depending on your torque that you need to apply. Typically, for this type of small screws, a small screwdriver is enough. This way, you actually don't over torque the screws and damage them. Just to give you another example, can I use the test pen to unscrew my securing nut? Let's say, for example, if I were to use this screw, can I use a test pen? Yes, of course, I can use a test pen, but is there a higher risk of damaging my test pen? Because some of these 3-pin plugs can be a little bit difficult to unscrew. So always use a suitable size screwdriver to tighten or loosen your screws. Now, I want to bring into the video an extension wire here. This cord is connected to my supply, and if I were to turn it on, I have actually supply now coming in to the lower port. Now, one thing I could do with the test pen is, if I were to slot it in sufficiently, I'm not sure whether you can see the light there. There's an orange color light that is illuminated. Now, this is illuminated to show me that there's power available in this socket. If I were to release my index finger, the light will go off. Any finger I put there, my light will come on to tell me that there's power in the circuit. But do bear in mind that when you have such a test pen, please make sure that it is not damaged in any way. The casing is intact, there's nothing seriously damaged, because when you are testing some of these circuits, if it's damaged in such a way that current can actually flow through you. So you don't want that to happen. The other thing that you have to be very careful when using is that when you are testing such circuits to determine if there's power available, please do not touch any exposed portions of them. These exposed portions will allow the current to go through you. So please be very, very careful. Always use a test pen that is covered or insulated to some extent so that you will remain protected. I want to actually use the multimeter to show you how it can be used for voltage measurement in an AC supply. Okay, I have an AC supply here that's already connected and it's turned on. How to determine, in addition to the test pen, that there's an AC supply coming in? You will need a multimeter like this that can measure AC supply. Turn it on to this V symbol here, and then you have to switch to AC supply. How do I know it's AC supply? I can see a curve down here. This is called a sine curve. Now, you have two probes on your multimeter, the red and the black. The two locations that I want to measure are these two locations. You will notice that there's a change in figure down here. Now, I will put my black probe in first, followed by my red probe. Now, you actually get a reading of 243 volts thereabouts. So that tells me that there is an AC supply of 243 volts coming to this socket. Now, another use of this multimeter, although I prefer not to do it, but it can be used as well, I can use this to measure DC supply as well. Now, your DC supply is the next one, the straight line and the dotted line. So by selecting the DC supply or DC measurement portion of it, I can now measure whether my battery is good to some extent. I have my two probes, one probe on this side and my other one on this side. This tells me that this battery is now supplying me with 1.484 volts. But it doesn't clearly tell me, is my power good? Is my battery really that good? Because this battery is supposed to supply 1.5 volts. Now, I want to introduce to you another interesting gadget that is a battery checker. I bought this online and it clearly states when I should be replacing my battery. There's a red replace here. There's an amber low here and there's a green good. Let's try it out and see whether is this battery a good one. The orientation is this way. Once I put it in, hold it there, and then I slide this little gadget here, this battery checker now tells me that this battery is in good condition. I can continue to use it. It's very useful because, for example, my remote control, does it have a battery problem or is it a remote control problem? There are occasions where individuals may throw away their batteries thinking that the batteries are no good and replace it in the remote control, and now suddenly the remote control still doesn't work. So this is a very good gadget to have at home, very inexpensive. I'll provide the link in the description. Now, your multimeter, not only is it useful for voltage measurement, DC voltage, AC voltage, it can also help you determine the condition of my wire. Now, why do I need to determine the condition of my wire? Is because that is basic troubleshooting. Before you even go on deeper into the defect, before you even go on to find out why your appliance is not working, check the wire. A simple wire like this is just for demonstration purpose. I go to my continuity check symbol here, the third one. It looks like a Wi-Fi signal over here. I select, the symbol appears up here. I do a simple test to see whether my multimeter is working, and you can hear the sound. So what this does is basically sends a very small current through my wire from one end to the other end to determine whether my wire is in good condition. Let's try this out. Okay, so by doing this, you can actually determine that you hear the sound, you can determine that the wire is good. This is a brown wire. Let's try another two more. Okay, this wire is good, and let's try another one more. This is also good. Now, in a 3-pin plug, you will come across fuses like this, which we've shown before. You can do a continuity check on this as well to determine whether does it need to be replaced. In this case, the fuse is good. Now, if the fuse is no good, as there's no continuity, you won't have a sound coming through your multimeter. Now, let's do another check on this wire here. This wire has got a 3-pin plug on it, and these 3 pins coincide with these 3 wires. The green is basically this bigger pin. Your blue is for your neutral, and your brown is for your live. So let's try it one by one and see how it works out. We are going to do a con check. Let's do my brown live wire first, which is here. I'm getting a good sound, a good clear sound. Let's do the neutral wire. Okay, I'm getting a good clear sound. And let's try the ground wire. I'm not getting anything. There's no sound. So that tells me something, that either there's a break in this wire somewhere along the coil, or there's an opening somewhere in the wire. Now, how do I determine that? The first thing I got to do is, the most simplest thing is to open up my plug using the correct tools once you have unscrewed it. And then now you suddenly notice that the green wire is disconnected from here. So now this is how you do some basic troubleshooting to determine whether your wire or your supply is good. Now, how do I fix it? I just have to put this wire back inside of here, do another continuity check using the multimeter, and it should work. So this is just to give you an example how we can use the continuity check to determine, or at least do some basic troubleshooting before we even go deeper into the appliance. Now, earlier I had showed you 3 different colored wires. You've got your brown, green and yellow, and you've got your blue. The role of these 3 wires are basically your brown, your primary current carrying wire. This comes from, in a lot of cases, from your circuit breaker. Your neutral wire is your return wire back to your circuit breaker box. And your ground wire can be used in case there is a short circuit. When I say short circuit, means in case any of these 2 wires are open and there's current leaking, it can leak into this ground wire and prevent you from getting electrocuted through your appliance. So these are all color coded, but of course you have to look at what is your color code in your country 3. Typically in Singapore, these are the 3 primary colors that we use current day. I want to introduce certain basic calculations to help you just gain a bit more knowledge about the appliance that you're using. This is a Pro Steam iron, and there's a decal that comes on it, and that decal actually shows the model number, the voltage, and the power. Now, the voltage is between 220 to 240 volts, 50 to 60 hertz. This voltage is actually used in Singapore, and it's also a UK rating. The power consumed by this steam iron is 1400 watts. Now, how much current is being used on this appliance? There is a simple formula that we can use in which power equals to voltage times current. The current that is taken up by the appliance is actually now going through this fuse. From this live wire, it is going through this fuse. Now this is a standard 13 amp fuse that is provided by many suppliers. Now, typically when we determine the amount of current, in this case using a 230 volt and 1400 watt for this appliance is approximately 6.09 amperes. Now, if you give 25% allowance for wear and tear, you can actually use a lower rating fuse, but many suppliers just leave it at 13 amp. Now, the closest fuse that can come across that you can use for this is a 10 amp fuse. Now, question arises is, if my current draw is 7 amp, can I use a 7 amp fuse? No, I cannot. Can I use a 6 amp fuse? No, I cannot. I must use a fuse that is higher rated from my current draw. The role of this fuse is to provide some amount of protection so that there is no excessive current draw from my supply socket. If there's excessive current draw, in this case if it's 13 amperes and my appliance is now drawing 14 amperes, this fuse will blow to prevent my appliance from spoiling. Okay, so your fuse will actually cut off. So that's how you actually determine what size fuse you can use for this plug or UK plug. Alright, that's all for today. Thank you for watching our video. Please subscribe to our channel, and I hope to see you soon. Bye!